Perfect.
Hi, Julia.
All right. For those of you listening at home, hi, Julia.
Hi.
Let's
Howdy. Howdy.
let's get started, gentlemen. Focus up here, please. Your reaction in the first 3 seconds of my saying that was not very
We got
encouraging.
this in humanities.
Quick question. Okay.
Sorry.
You should have done. So you got your notes, please.
I'm scared. This is our homework.
Okay.
The natural log. I hate the natural log.
This is not all going to be due at once. You're welcome to start at once, but there are a couple of notes you'll need for last problem discussion. Okay, face fronts. Is this on topic?
Yes.
Please.
I still need to get my second half checked off.
Okay, let me do that at the end of the hour, but remind me. Ladies, gentlemen, is everybody attending me? Write down the following. Can somebody give me the formula for integration by parts? You should get this memorized soon. But look in your notes if you need to. It's an actual equation, it's the integral of something. Got it? Go. Integral of what?
The antiderivative
Uh-huh,
of u dv
correct.
equals uv minus antiderivative of v dq.
Correct. Start memorizing that. I would ideally like you to have this memorized by the end of the week. Gentlemen, whatever topic it is, you can wait till the end of the hour. The integral of u dv, and you'll notice 2 different letters there, that's deliberate, is equal to uv minus the integral of v du. The trick for integration by parts, why are we still chit-chatting? Let's not. The trick of integration by parts is that if you have 2 things multiplied that don't simplify, that don't just use plain old substitution, that don't match, then you can, Pete, what's the problem? Pulled blood. You're still? I'm literally looking at you gentlemen, and your mouth is still moving, and I can tell when you're on topic and when you're not, honestly. I think most teachers can. Stay with me. If you have 2 functions like x times sine of x, where they just don't simplify, you can't combine them, and there's no easy way to simplify, this might work. Again, this is not guaranteed, but we're going to be collecting tricks for how to integrate things that are hard or tough or tricky. So can somebody put this to the test? In order to get integration by parts to work, you have to find a piece that looks like a u and a piece that looks like a dv. In other words, something that looks like a non-derivative and then something that looks like a derivative. I would suggest, again, sometimes you just have to do trial and error. There are some things where even somebody who's really experienced at these say, I don't know, let's just try something. And you try it and it doesn't work, that's not a problem. Just try something else. There might be like 3 or 4 or 5 or 10 different ways you can do integration by parts, matching up the pieces, especially if there are like 5 or 6 things multiplied together. So you might have a clump of 1 as being the derivative and a clump of 1 as being the non-derivative. I would suggest for something for u, so the derivative of this should be easy, or at least easier. It shouldn't get any harder. And then here, the antiderivative of this is easy. Does that make sense? Whatever you pick for the letter u, it should have a derivative that's not too bad. And whatever you pick for dv, make sure that you can take its antiderivative without any real great pain. So, any possibilities? There are at least 2 possibilities for setting up the u and the dv on this problem. Go.
Well, last class we did x sine of x dx, just as the example problem.
Okay,
Would it be okay if we just did that one too, because we already have a couple notes on it?
absolutely. And it's the same technique. Do we finish that one?
We tried one,
Oh,
and
and
we didn't do it, so then we're gonna pick up next class with
Perfect.
u being, x, I think.
Okay. Let's try it. U equals x, and then dv is equal to what? How would you do that? And it'll have to have a d something at the end in order to be legal.
Cosine of x dx.
Cosine of x dx. Does that make sense? So make sure the dv has a dx or whatever at the end. That makes it look like a derivative. And make sure this thing does not have the dx. Now, in order for the u to work, the derivative of u should be easy. Is that the case? Is the du a nice derivative? Pete, take over.
Yes,
What is it?
1
Yeah, 1 what?
dx.
Dx. You can do a 1 or just a dx. It really doesn't matter. They're both the same thing. That was a relatively nice. This is looking good for a substitution. For dv though, can you go back in time and tell me what v was? Max, take that one.
Sine of x.
Sine of x with one extra thing. Plus c. Good. Does that make sense? This seems to have a lot going for it. The derivative was nice on this part, and the antiderivative was nice on this part. Let's see if it works though. The trick is when you notice it kind of switches the integral around. It has the u and the dv, and now we have the v and the du. They're hoping that this is going to be an easier integral. Let's see what happens. Equals. Here's the formula. uv minus the integral of v du. So it's going to be something times something minus the integral of something, something. Can somebody fill in the relevant somethings? I could probably take this one. What's the u?
X.
X. What's v?
Sine x plus c.
Right, sine of x plus c. And I'm just gonna put the plus c at the bitter end when we're done. Because there's gonna be a c here, then another c here, and another c. We'll just glom them together into one big c. What goes here? Keep going.
And then x, is that a v, sorry?
That's a v.
Okay, and sine of x plus c,
Yeah,
or
and there's
just
another,
sine of
just,
x
you can just do
together.
sine of x, because I'll put all the c's in here. And then what goes here?
dx.
Correct. Is everybody okay with that? There was a relatively small thing to put in for du. Let's see what it looks like in real life. Let's simplify. This is x sine of x. You don't have to do anything with this. We're not taking the antiderivative, it's just sitting there. Minus the integral of sine of x dx. Does that look like something we can do? Michael?
Yeah.
Yeah, we can take the antiderivative of sine. It's close to one of the ones I had you memorize.
Antiderivative of sine is just cosine.
The derivative of sine is cosine.
Oh, yeah, it's,
Close. If you have to go back in time,
well, it can be,
think that through. So what's the derivative of sine again?
the derivative of sine.
Just the regular
It's just
derivative.
Cosine,
Cosine. Cosine of x dx.
yeah.
What's the derivative of cosine of x?
Negative sine x?
Yeah.
Oh, so just distribute the negative.
Yeah, so here, I would love for it to be negative sine of x. You can actually pull this thing back inside. Oops, should be minus. Does that make sense? Normally we pull it out, but if it helps you, you can pull it back inside. What's the antiderivative of negative sine?
Cosine.
Regular cosine. So it's x sine of x that is just sitting there, plus cosine of x, and then plus what? What's the one thing we don't have yet?
See?
C. You're looking at your answer. Does that make sense? And I think I just did one of the problems for you, or something close to it. Is it number 4, I think?
Okay.
Congratulations, yes. Yeah, sure. Yeah, it is number 4. Oh, they actually give, okay, just so you know what's coming up in the worksheet, 1 through 4, the worksheet was being very nice to you. They gave you the U and the DV just for practice. Then 5 through 8, you have to find a U and the DV. Now, some of those are going to be similar in pattern to number 1, 2, 3, 4, so you can feel free to look back. I do want to show you a tricky one though. And then I want to show you, well, 2 tricky ones. And then I want to give you a respectable amount of time to work. But I think I have a total of 3 examples. Is everybody okay with integration by parts? The formula and stuff? Okay. Again, start memorizing that, because I guarantee you one of the test questions is going to be, what is the formula for integration by parts? And you'll say the integral of u dv is equal to uv minus the integral of v du. Guess what I'm about to say? The man's smart. Now, try this. Go ahead and write it down first. But question, does anybody remember the derivative of ln of x? What's that? It's 1 over x, correct. Do we know the antiderivative of ln of x? Is it on a list anywhere? In other words, can we take the derivative of something and get natural log that we know of? Yeah.
Well, the log, or the natural log, is just what it is, like, isn't it just 1 over x?
That's when we take the derivative, yes.
Oh,
If you take the antiderivative, have we ever done that?
wait, is it just b? Oh, wait, yeah, we did. Give me a second.
Okay.
It is, negative, wait. Oh,
That should be on screen.
uh,
Hi, Joe.
wait, isn't it just, isn't it just natural log of u plus c?
Natural log of u plus c. No, it's a nice guess. The antiderivative, you're thinking of this. The antiderivative of 1 over x dx is the natural log of x plus c. That's true.
Oh, okay.
Now, what if you go 1 step further and try and take the antiderivative of the natural log? Have we ever done that? Take a wild guess.
Yes. Wait, what?
Don't look at my face.
We had.
I didn't hear what you asked.
Have we ever done this before? We've taken the derivative of natural log, it's 1 over x.
Yeah, we take this.
The answer is no. We've never taken the antiderivative of the natural log. So how do you do it? Is there anything we could substitute? Like, there's basic substitution, then there's trig, and then there's integration by parts, and those are really the only 3 tricks we know. So for antiderivatives, either it's, well, I guess 4. There's a basic one, the power rule, or it could be a trig, which it isn't, or it could be substitution, plain old substitution, or it could be integration by parts. So question, let's try substitution. What would you use? I'm not guaranteeing it's going to work, but there's really only one option that I can see. If you did x, it would turn into ln of u du, which is the same problem with a different letter. Nice try. There's only one candidate for the letter u. What would it be, Jack?
What? Sorry.
What's the only candidate for the letter u if you want to try regular substitution?
ln.
Yeah, ln of x.
X. ln of
That's
x.
the only thing in there. So what's du? Michael?
dx?
What's the derivative
Oh,
of
yeah,
natural
yeah,
law?
No. That's what I'm saying. That's what I'm saying.
And make sure you get this memorized soon.
Du is, oh, it's the derivative of u, so.
What's the derivative of the natural log of x?
It's 1 over x.
1 over x.
Let's see.
That's antiderivative.
dx.
dx. 1 over x dx. Let's see if this is poised to work or not. Julie Milan, is ln of x in there somewhere?
Yeah.
Yes, that's you. Is 1 over x in there somewhere?
Yeah. Well, no.
No. No fault of our own. Regular substitution failed. Because 1 over x has to be in there somewhere. 1 over x dx has to be in there, and it just wasn't. It wasn't our fault. It's just not there. By the way, if somebody had done this, what is the problem? Gentlemen, I'd be happy to separate you if you cannot stop talking to each other. But I need your attention and I need your quiet. Is that understood? Thank you. Try it. Take a look here. ln of x over x dx. Question. Could you use substitution here? Prove it. No, what do you think?
So you can pull out the 1 over x.
Yeah, u is equal to ln of x, that's in there. And then du, if you notice, there's a 1 in front. You can rewrite this as the integral of 1 over x times ln of x dx. Lo and behold, look what's there. That's a completely different problem, by the way. It's not this. But if this were the problem, you could actually do regular substitution. They might hide the x in the bottom, that's really 1 over x. That would work. If that were the problem we're working with, which it's not. Regular substitution simply does not work on this. I'm going to show you how to do it. It's not obvious, but it is a technique you already know. The first time I saw this, my reaction was, you're kidding me. Like, no, this is a practical joke. You can't possibly be serious. Watch this. The only time we've ever used integration by parts is when you have 2 separate functions multiplied together that look alien to each other, like x and cosine of x. I don't see 2 functions here, but there are. Somebody had the idea of trying integration by parts. Now choose carefully. Which part would be used for the letter U? One of them should be able to take a derivative easily, and one of them should be able to take an antiderivative easily. Which is which? Go.
Well, you can take the derivative of the natural log easily.
Yeah, what is du?
1 over x dx.
Yeah, we did that earlier. 1 over x dx. We'll hand that in a second. Now, what part would you use for dv if that's the case? John. What's the only piece that's left?
X dx.
The x is part here.
Or
Yeah.
dx.
Yeah, just plain old dx, or 1 dx. So, take the antiderivative. What would it be? What's antiderivative of 1?
X.
It's x. It's plus c, but we'll put that at the end of the problem. Let's just see if it works. Now, the regular substitution is still not working. But can somebody give me the integration by parts formula? Yeah, question.
So on our worksheet, it
Uh-huh.
says that dv is. Oh, sorry, never mind.
Okay. Yeah, problems 1, 2, 3, 4, they actually gave you the u and the dv. That was just for being nice. What's the formula for integration by parts again? Max, rattle it off for me.
U dv equals uv minus v du.
uv minus the integral of v du. So I'm going to put these things here. What is u in this case?
Natural log of x.
Yep. What's v? What's v? Keep going.
I can't.
X. What should go as v?
X.
X. What about du?
Number x.
Tell me what to do next, so math people. Is this going to work? Let's find out. I mean, I don't know. This I would write as just x ln of x. Just put the little piece first. You do not have to do anything else with it. It's done. You're not taking the antiderivative or derivative or anything. Minus the integral of what? Does anybody see it? It's much nicer than you think. Go.
Just x dx?
Close. Even nicer. Yeah.
Is it just x?
No, that's what he said. You're very close.
It's just dx.
Oh, just what?
Dx?
Just dx, is that what you said?
No, I did.
Oh, okay.
Looks like it'll be one exactly.
These cancel, and it's 1 dx. You see that? X times 1 over x, just algebraically canceled. What's the antiderivative of 1? B. This one.
The antiderivative of 1 is x.
X, correct.
Is that-
And then at the end, plus what?
C.
C. You're looking at your answer. If you take the derivative of that, you will get natural log of x when you simplify it. That is not obvious. I mean, nobody would have known that off the top of their head unless they were a math prodigy. I'm not. But let me,
I think we might be the Chicago.
no. Thanks for the thought. Quick 45-second story. In high school, you know what a subject GPA is? Grade point average for, like, for history or for whatever. Guess what my lowest subject GPA was in high school?
No.
It was math. Yeah. I would learn the stuff, and I would learn it well about 3 weeks after the test. It just didn't soak in. I would stare at it and stare at it, and everybody else in the room would say, oh, okay, yeah. What? I always felt like I was missing the train for my entire life. I mean, the standardized tests went pretty well, because those are like a year after when I learned it. So that was fine, but yeah, my subject GPA took a beating. Guess what was my second lowest subject GPA in college? Good guess, but I avoided the history classes like the plague. No. Yeah. The only one that beat me out was computer science, and that's because I had the first one did really well, and the second one was a horrible story. I'll tell you later.
Can you tell us
But-
how?
Yeah, what's the story?
It was a, well, the real short version is, it was taught by a professor who had a PhD. The college required all their PhDs to teach a course. He did not want to teach a course, he just wanted to do research. And he made that very clear on the very first day of class. He didn't want to be here, he wanted to do research, the college was forcing him to teach. The class went downhill from there.
Yeah.
Almost everybody else passed the class, but because they had the material in high school, and I had never seen it before in my life. I passed with a D by the skin of my teeth. And I think he was actually being nice, in that limited respect. So he and I actually did reconcile before I graduated, but he was not on my favorite person's list. Anyway, moving on. So in case anybody comes in for office hours, I try him, he taught me a lot of what not to do. He was pretty, all right, fine, a little bit of a, I don't want to besmirch the poor man, but I'm not going to tell you his name. I think he's gone on to his reward too. So, God rest his soul. But I came into his office hours because I was totally, completely lost. And he sat down and he said, do you have your book? I said, yeah. Do you know how to open it? Yeah. Do you know what an index is? Yeah. You were looking up something called 2-3 trees, right? I would suggest looking under T. This was like a half hour of this. Most miserable experience I've ever had. I tried to drop the course, but it was too late in the year to drop it. By the time I realized I was gonna crash and burn on this. And so, wow. Again, he and I did kind of reconcile on it. I'm not sure he even realized what a jerk he was being, but he and I parted on good terms, so I prayed for him. But yeah, if you ever become a teacher, but if somebody comes in for help, treat them kindly. They're there for help with their mind and heart open. and they say, I've been there, I'm okay, we'll work through this somehow, I don't care if it takes 2 hours, and by the way, you're smart. Don't make people think they're dumb. It's not pleasant. All right. How much time do we have? 25 minutes? I would like to show you one last example, and then I'll give you some time to work. So I've given you 2 examples first. One is x cosine of x antiderivative. And the integration by parts is pretty straightforward. The antiderivative of logarithm of x dx was still integration by parts, although it wasn't easy to tell the pieces. Are we talking about something relevant to here? Yeah. I don't quite believe.
I was just asking if you know.
Yeah, okay. In other words, the topic that I'm talking about is very instant.
Sorry.
So that's fine. Just, and you're smart, by the way. Now, let me show you the last thing. Try that one. First of all, does this look like a candidate for integration by parts? Yeah, it looks like a function times a function, and the 2 functions don't have much to do with each other. They can't simplify, you can't, add the powers or anything. You can't convert one to the other. So, let's see what we can do. U equals something, and dv equals something. And again, the formula is the integral of u dv is equal to uv minus the integral of v du. Pick a letter u and pick a thingy dv that you think will work. Again, the u should have an easy derivative. The du should have an easy antiderivative. It doesn't have to be your favorite antiderivative in the world. It just has to be relatively easy. Yeah.
I would say use probably sine of x.
We can try it. Because there are 2 candidates, and right now it's up in the air. And then dv is x squared dx. By the way, this is a logical choice. Both of them are logical choices. Let's pursue this and see what it looks like. Can you find du and can you find v? So what would du?
Cosine of x.
Yeah, cosine of x dx. The fact that that's not in there is, in integration by parts, it's not necessarily lethal. Because we might just have it in front, like here. I mean, who knows? What's the antiderivative of this? Do we know? Integral of x squared?
1/3.
1/3?
X to the third.
X to the third. And
times
with a,
x. Oh.
actually no, you're
Oh,
good.
just
And then
plus
just
c.
plus c. The dx gets sucked back in and disappears. So it's 1/3 x cubed with a plus c that we're going to put at the end. Let's try this out. The integral of u, so we're going to do sine of x, and then x squared dx. According to this, it's going to be what? Oh, they talked me through it. What would the letter u be?
Sine of x.
Yep. And then what's v?
1/3 x cubed,
Okay.
and then you can add
With the plus c, blah, blah, blah. Yeah, good. And then minus, oh, sorry, wasn't supposed to be the integral yet.
That's minus the
Integral.
antiderivative of 1/3 x cubed
Uh-huh. And what's du?
times x squared dx. Or sorry, cosine x.
Cosine of x dx. Sorry, I'm squishing it. Everybody see what we have so far? I've got good news and bad news for you. The good news is here, you don't have to do anything else. I just move this to the front. 1/3 x cubed sine of x. That part's done. You don't have to take an antiderivative of anything. Whether it's ugly or not, that part's safe. And now, by the way, what can you do with that 1/3? If it's a multiplied 1/3, what could you do? You can pull it out in front. So minus 1/3 antiderivative of x cubed cosine of x dx. Now remember, integration by parts replaces one integral with another in the hopes that the new integral is easier. Is it? compared to the original, x squared sine of x, it's now x cubed cosine of x. Is that better or worse?
Worse.
It's worse. Through no fault of our own. That will, put it in the back of your mind, when you do integration by parts, an integral of a polynomial is going to get bigger. We want it to get smaller, as a general rule. I mean, there are exceptions. But for right now, again, this is a totally logical choice. Because the derivative on this was easy, the antiderivative of this is easy. Who wouldn't try that? It's just sheer bad luck that the new integral is harder. It's getting bigger and bigger and bigger. And if I try it again, it'll go to the 4th power and the 5th power, 6th power. It's not gonna die, it's gonna get worse. It's gonna eat Grand Rapids. So, unfortunately, this didn't work. There's one other choice. And by the way, if you are thinking to yourself, oh, I just wasted 10 minutes of my life doing this, don't think that. Remember there was a quote by Thomas Edison. It says, I haven't failed, I've just found 9,999 ways that didn't succeed, or that didn't work, and I eliminated them. So the 10,000th way must be the right one. It's supposed to cheer you up. So what is the letter U in this case? Michael, take over. What should you use as the letter U? And again, this is totally logical. Just store into your head why it didn't work. Not because they weren't good substitutions, but because it just, integration by parts just happened to make it worse. So what do you think? What would you use for U? We tried sine of x and it did not work.
So x squared.
Yeah, that's the only logic. Would anybody suggest U equals x? Can anybody see what's wrong with suggesting U equals x? We did that the other day. Does anybody see what would happen?
Oh, it's just like literally changing the variables.
Yeah, just completely change. It would be U squared sine of U du. It'd be the exact same problem with a different letter. No closer to solving it. So U is equal to x squared. Pete, what's dv?
dv would be sine of x dx.
Sine of x dx, correct. So what's du? Paula.
Would that be 1/3?
That's an antiderivative. We're taking a regular derivative.
Oh, sorry, 2x.
Yep. And then dx, correct. What's the antiderivative of sine? Max, take this one. What's the antiderivative of sine? There's a little bit of a pun in there too. Be careful of the sign. So, go ahead.
Cosine.
Very close. The derivative of sine is cosine. The derivative of cosine is negative sine. So how do you get regular sine?
Negative cosine.
You had to start with negative cosine. Does that make sense? And then there's a plus u we'll put at the end. The derivative of regular cosine is negative sine. So the derivative of negative cosine is positive regular sine. Let's try it. Here's the integral of u dv is equal to uv minus the integral of v du. Let's try it. I hate to do this to you, my friends, but Pete. Things can be restored if things return to normal. Noah, take over. What's u?
U is x squared,
Okay, keep going.
and then v is negative cosine of x. We'll say the plus u later.
Correct.
And
Then what goes here?
Negative cosine of x,
Yep.
and then 2x dx.
2x dx, correct. Now, let me sweep this up. Everybody look up here. Just visually look up here. Do you see this x squared times negative cosine of x? I have seen people do this just because they're feeling rushed and careless. Is that right? Absolutely not. This is not subtraction. I would pull the negative in front. It's negative 1, really. So it's negative 1 x squared cosine of x. And then that's all you have to do with that part. It's done. Notice, minus a minus, you can pull the minus out and make it positive. Integral of 2x cosine of x dx. I'm gonna pull the 2 out in front. So it's negative x squared cosine of x plus 2 antiderivative of x cosine of x dx. Question for you. Pete, take this one. Is this integral easier or harder than the original?
Easier.
Easier. What makes you say that?
Well, there's no, the x isn't squared.
Right. The power on the x went down, and sine and cosine are kind of the same level as far as difficulty. The derivative of sine, derivative of cosine, it's kind of the same easiness. So we're not done, but do you remember what we just did x cosine of x dx antiderivative? Can somebody give me the answer to that one? This thing we already did. So there's bad news and good news. The bad news is we have to do integration by parts again for this thing. The good news, two pieces of good news. Number one, it's easier. And number two, we already did it. So we're just gonna copy and paste the answer that we already did. So basically, we're going to do the integration by parts. So let's do it. Twice. Does that make sense? Because you've got another integration by parts candidate here, but it's an easier one. So you do another u, another dv, blah, 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 blah. And then can somebody read off the answer to the previous one we had? I'm gonna leave this first part because it's done. Negative x squared cosine of x plus 2 times what? What did we get for x cosine of x in the derivative? Somebody read it from?
What will we get for what?
We did this earlier this hour. There was an earlier problem. X cosine of x dx.
It was x sine of x plus cosine of x plus c.
Plus cosine of x
Yep.
plus c?
Yep.
Correct. Now distribute the 2, and then we should be done. So go ahead, Jack. Read it off from beginning to end.
So you have negative x squared cosine x
Yep.
plus 2x sine of x plus 2 cosine of x
Good.
plus
There's
c.
2 cosine of x plus just capital C. If you wrote 2c, I would not mark it wrong. I would look at you funny. But c is like infinitely stretchable. Does this make sense? So if you run into a problem where it seems you have to do integration by parts again, that's legal. I will not do that to you very often. As a matter of fact, let me just tell you what you need to do for your assignment for tomorrow. For your assignment for tomorrow, I just want 1 through 8. And that's it. 9 through 14, just so you're aware, 9, 10, 11, and 12 are, you might need to do a weird substitution. I'll give you a hint on number 10 because number 10 is, oh no. Oh, fluffing well, your assignment just got a lot shorter. Scratch off number 9 and number 12. We have not come near covering what those are. We did them in pre-calc. They're called inverse cosine, inverse tangent, but nowhere near finding calculus for those. So 10 and 11 you should be able to do.
Wait, are we doing 1 through 8?
1 through 8 for tomorrow.
Okay.
And then the next day's assignment is gonna be a lot lighter than I intended. Stupid computer. Lovely computer. Number 10, allow me to do a suggestion. This should look a heck of a lot like something we did earlier this hour. May I make a humble suggestion? This is what's called a double substitution problem. First step, I suggest you write this down in number 10. Do this, capital A equals x plus 1. Capital A equals x plus 1. Now rewrite the problem for me. This is a regular substitution. In other words, you're going to do substitution twice. A regular substitution first, and read it off. What does it look like now? The antiderivative of what?
A, I mean, ln of A.
ln of A, d, dA. Because what's the derivative of x plus 1? It's even smaller. The 1 disappears, it becomes 0. What's the derivative of x?
dx.
Yeah, 1 dx. So the derivative of a, if a is equal to x plus 1, then dA is equal to dx. So the whole thing we'll rewrite as the integral of ln of a dA. Now do integration by parts. So it's going to be another substitution with u and dv. Do you see what I did? The first wave was substituted just so it looks nice. Then the second wave is do integration by parts substitution so you actually do the problem. And when you're all done, substitute everything back. All the a's should be replaced by x plus 1s. Does that make sense? Those are you don't have to do those for tomorrow, although if anybody wants to try them, that's how you do this. Number 11, that should be a regular substitution problem, and you may have an integration by parts as well. Number 9 and number 12 are dead, so don't worry about them. 13 and 14, I would not recommend you do them yet, especially number 14. That has a super duper sneaky trick, which I have not shown you yet, which I'll hopefully show you tomorrow. For now, 1 through 8 for tomorrow. You have the rest of the hour. Let me know if you get stuck. Okay? And for those of you who are listening at home, hi Julia. We will talk to you soon. I'll post this on YouTube. Click the like button and subscribe. And this is my hand waving goodbye. See you later. Bye.